All right, so we've been working on multiplying multi-digit whole numbers by a one-digit factor using the distributive property and area models and those type of things. And today, all devices are closed right now. All devices. Thank you. And so today, what we're going to focus on is we are going to begin looking at how to use the standard algorithm to multiply. And we're going to focus on how would we regroup when we have to multiply. Because, when you add, you have to regroup sometimes. You have to carry the one or carry the whatever. You know what I'm talking about? Sometimes you have to do that as well when you multiply. And so that's what we're going to look at today. So if we look at our example up here, it says 3 times 46. And we're going to estimate that to say, well, 46 is pretty close to 50. So I think my answer is going to be close to 3 times 50, which is 150. So our first step is we're going to line up our problem stacked on top of each other. And then we multiply in the ones place. So we have 6 is in the ones place. So I'm going to multiply 6 times 3. And what is 6 times 3? It's 18. And we cannot put a 2-digit number in a 1-digit slot. Like that doesn't work. So we have to think to ourselves, how can I regroup 18 ones when I add? Because adding and multiplication are related to each other. So how do we regroup when we add? What do we do? What do we do, Jada? Right. You take the tens place and you put it at the next door neighbor. Exactly. So we regroup the 18 ones as 110 and 8 ones. So we put the 110 in the tens place, and then we put the 8 ones in the product. So all devices are closed.
Yeah, we're just doing this.
But are you focused on the math? Yeah. No, you're not. So let's keep the devices completely closed. I know it's a cute little trick. I get it. My kids try to do it to me too. I understand. I get it. But let's just focus on the math, okay, guys? Y'all are so cute. Thank you. Y'all being so sweet. I appreciate y'all. Okay, so now our second step is we're going to multiply the tens place. Now, when we add, we just go straight down. We work from top to bottom, answer. Top, bottom, answer, right? We work in columns when we add. When we multiply, it's a little bit differently. Remember when we broke it apart and we had to multiply all the parts of that number by the one-digit factor? Like when we did our area models and we had those big rectangles spread out and we had like 200 plus 30 plus 1. And we would have to multiply 200 times whatever, 30 times whatever, 1 times whatever. You remember that? So we're going to have to do the same thing when we multiply using a standard algorithm. We're going to have to multiply all the numbers on top by the ones place, by the one column, the one factor. So I've already done 6 times 3 was 18. I regrouped my 1 and I put my 8 down. 18. Y'all see that? Now I have to multiply the tens place. I'm going to multiply the tens place times the 3. So 4 times 3 is 12, but I have to add this 1 to it. 12 plus 1 more equals 13. And I could actually regroup that as 103 tens. So 3 times 46 is 138. And because 138 is close to the estimate of 150, that's a reasonable answer. Let's look at number 1. So I need to find 5 times 23, and I need to check whether or not my answer is reasonable. Well, I know that 23 is close to 20, so I'm going to multiply that just to get an estimate. 5 times 2 is 10, and then I have a 0 behind it. So my estimate is going to be somewhere around 100. So I'm going to start in my tens place. No, I'm not. I'm starting in my ones place. and I'm going to multiply 3 times 5. What is 3 times 5?
15.
Right, 3 times 5 is 15. But I can't put 2 digits down here. So what do I put down here?
Yeah, 5.
I'm going to put the 5, and I'm going to carry the 1. I'm going to regroup that 1. Is everybody okay so far?
Yes, ma'am.
Okay. Well, maybe when we do some more practice, it'll start to click, okay? So now that I multiplied in the 1's place, I'm going to move to the 10's place. And I have a 2 in the 10's place. So what am I going to multiply the 2 by?
5.
Yes, right, exactly. I've got to multiply both those top numbers by the 5. So I'm going to multiply 2 times 5. And what is 2 times 5?
10.
Plus that 1 that I carried.
11.
It's 11. Now, is 115 close to my estimate of 100?
Yes.
Yes, so it's reasonable. It is reasonable. Okay, so let's look at these models to find the product. So this is that same problem I just did, 5 times 23. And let's see if we can figure out how this model worked. What is in one group here? What do I have? 20. So this is one group of 20. How many groups of 20s do I have? So I have 5 groups of 20, right? So that's like saying 5 times 20. What is 5 times 20? 100. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In other words, I've got
150.
5 groups of 3. And 5 times 3 is 15. So when I add this partial product and this partial product, what do I get? 115, which is the exact same thing that I got when I did this problem using the standard algorithm. So here we're doing 4 times 35. So I know I'm going to have 4 groups of 30. 1, 2, 3, 4 groups of 30. 4 groups of 30. And then I'm going to have 4 groups of 5. 1, 2, 3, 4, 5. What is 4 groups of 30? 4 times 3 is 12 with a 0 on the end. What is 4 times 5? 20. And if I add 120 plus 20 more, I get 140. Okay? So let's look at a couple more just to get it in your brain. Here they've given me the estimate because 14 is close to 10, and 10 times 7 is 70. So it should be around 70. So remember, we start in the 1's place. 1 times 7. I don't know why I said 1 times 7. I guess because I said the 1's place. 4 times 7. What is 4 times 7? 28. What do I put here?
2.
Good. I put the 2 here, and what goes down here?
88.
Do y'all see how that's 28? So now I'm going to multiply the 10's place. So I'm going to multiply 1 times 7. And what is 1 times 7? Plus 2 more? 9. Is 98 pretty close to 70? Yeah, I mean, it's not like, right, super far away. So it's okay. So let's look at number 4. 48 times 9. I know that 48 is close to 50. And 50 times 9. 5 times 9 is 45 with a 0 on the end. So my estimate is going to be somewhere around 450. What is 8 times 9?
72.
Good job. What do I put up top? 7. 72. And now I'm going to move to the 10's place. I'm going to multiply 4 times 9
36.
plus 7 more.
43.
Good. 43. Is 432 close to 450? Yes, so it's fairly reasonable. Okay, so your job today is going to be to use the standard algorithm to multiply a 2-digit number by a 1-digit number. I'm going to put your assignment on Google Classroom. It's not up there yet, but I'm going to get it there in just a second. All right? So you may begin logging into Google Classroom.